Hello, this is going to be a quick video on some of the harder geometric theorem related questions that come up. So here's one that often comes up, okay? So here you have a triangle, and let's say the distance from there to there is 4. The distance from there to there is A. The distance from there to there is 8, and the distance from there to there is 5. And these are parallel to each other, okay? So, and you're asked to find A. So the trick with these is to understand that you have two similar triangles. Now, similar triangles are not congruent, but they are identical in angles. So if you look at this smaller triangle here, this angle is in it. It's also in this bigger triangle here. So that's one angle they have in common. Because these lines are parallel, this and this are the same, which means they have two angles in common, the big triangle and the small triangle, which means that this and this must also be equal, because if two angles are the same, the third angle must be the same. Okay, so these are similar triangles, and because they're similar triangles, the ratios of the sides will be the same. So in other words, if I get the length of this small side, it corresponds to the length of this big side in a ratio form. So in other words, A, whatever it is, divided by the length of this full one, which is A plus 4, must be equal to 8 divided by 8 plus 5, which is 15. So now that I know that, I can solve this because I can multiply both sides by 15 and 8 plus 4. In other words, I can cross multiply to get rid of this fraction. So on the left hand side, I'll have 15 times A equal to 8 times A plus 4. So that's 15A is equal to 8A plus 32. Take 8 from both sides. What's that? 8A take away 15A is 7A is equal to 32. A is equal to 32 over 7. Okay, so that's how you do it. Now, you're not always going to get a whole number answer out of these because of the nature of your using fractions. Okay, it just won't work that way, but you do your best with it. Okay, so I will try and do another one, show you how this works. So again, you can spot the similar triangles, you know you're doing something right. So there's your parallel lines, and that's called this segment 4, this segment 8. And we don't know what these segments are, but we do know that the whole thing is 9. And let's give some letters on here to help us. A, B, C, D, and E. So if I'm right, then the big one, okay, so we don't know what it is, but we do know that this big one here, AB, is 12. We know this small one is 8. So in other words, 8 over 12, small over the big, should be equal to, on this side, small over the big. Well, I know the big on this side is 9. It's the whole length. The small, though, they don't give me anything. Okay? So if I just give it a number, let's call it X. Well then, whatever that number is, it's that number out of that number. So in other words, it's 9 minus X. So let's try and figure this one out. 9 eighths are 72 is equal to 12 nines are 108 minus 12x. Okay, so minus 12x is equal to 72, that's 28, 36. X is equal to 3. That one worked out nicer. Okay, so that's a simple one on similar triangles. Okay. So let's have a look at some ones on non-similar triangles. let's have a look at this one here. So that, 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 and that. Right. Right. Let's put some numbers in and let's find some things. So 55. And I want to find this angle here. Let's call it A. And I want to find this angle here. Let's call it B. So we have a theorem that shows you that this is half of this. So we already know what this angle is here. It's 110. If that's 110 and that's a circle, then that must be, A must be 110 take away 360, which is 270. So 250 degrees. Now, let's have a look and see how we can find this. Okay? So, if this is 110, what do you think this is going to be? Okay? So, if you look at it very carefully, there's a couple of ways you can kind of divine what this is going to be. Now, I say a couple of ways, but you know, it's like anything else. It's a matter of figuring it out if you can figure it out. Okay? So, if you look at this carefully, this is what's called a cyclic quadrilateral. All four corners of this four-sided straight line shape touch the circles independently, which means the four corners must add up to 360, which means opposite corners must add up to 180. So that means that B, if this is 55, then this must be 180 minus 55, which is 125 degrees. And ironically, it's also half of that, because it's following the same rule, just don't want to shock you, upside down. Okay, so just be aware of that.